Good evening. Today we are going to study about mass movements. It is a very important topic of geomorphology, and it covers its weightage in state PSC exams related to mining officer, assistant geologist, assistant geophysicist, etc. Also get some questions in NET exam also. Now, what we are going to discuss today. So, we are going to discuss about three questions today related to mass movements. First, definition of mass movements. What is mass movement? What are mass movements? Then, what are different types of mass movement processes like slide, flow, etc. And then at last we will study. We will look on why to study the mass movements. Uh, what is the need to study about the mass movements, and where we can use our study related to mass movements for geomorphological studies or geographical studies, etc. So we are going to start our discussion. So, introduction. By definition, mass movement is the downslope movement of the slope material under the influence of gravity. So it is very important to infer here that influence of gravity, gravitational force of the material itself. So according to the definition, we doesn't need any assistance of moving water, ice or air to transport our material downslope, or we doesn't need any assistance for assistance related to geological agents for mass movement processes. It's just a gravitational force of material itself which helps the material to transport downslope. Very large scale movements of rocks which are transitional to the tectonic processes can also occur under gravity. Some other movements can also take place due to gravity which can be inferred due to the tectonic processes, but we are not going to study those movements here or those processes here because that are out of our topic. The term mass vesting is often regarded as synonymous with mass movement, but it is also used in a broader sense to encompass all processes involved in the lowering of the landscape. Sometimes some people use mass vesting and mass movement as synonymous to each other, but there is a big difference among them. In broad sense, we use mass vesting definition or mass vesting term for the processes which degrade the landscape or which lowers the relief of the landscape, like denudation, like weathering, which can which can lower the relief of the landscape, and which are denudation type processes. But the mass movement, it's different from mass vesting because we use different types of processes here, which not only include the mass vesting process, but also include some processes which does not include lowering of the landscape. That is, there is no change in landscape in some processes related to the mass movement. So, mass movement processes. We identify six fundamental types of movement: creep, flow, slide, heave, fall, and subsidence. So today we are going to study about these six fundamental types of movements: creep, flow, slide, heave, fall, and subsidence. Each of these movements can then be divided into specific types of forms of mass movements. Most movements in reality involve a combination of processes. So in nature, we will see that these processes mostly happen uh, in combination, that one process involves other as well, and one or two or sometimes three to four processes are also happen together. For example, debris avalanche. We can see that the debris avalanche starts as a fall or a slide, but when the mass started to break up, it will take form of flow. So debris avalanche is a type of mass movement process which started as a fall or as a slide, but when the mass started to broken up, or they found the fragments, that mass movement process converted to flow type of mass movement process. Flows tend to be wet and slides dry. This is very important para. that flows flows tends to be wet, but slides are dry. It means it flows contain some flows contain some kind of moisture, some amount of moisture, maybe moisture sometimes abundant as well in solifluction like processes. While heave can occur over a fairly broad range of moisture conditions. So heave can be heave. We can say that heave can vary from wet to dry uh, scale. Heave processes are invariably slow, whereas both flows and slides tend to be rapid. So the process of heave mass movement is somewhat slow, but the process of slide and flow is rapid, generally rapid. There are some exceptions as well, which we are going to study. Now, classification of mass movements in terms of pure flow, slide, and heave. Here we have divided, or we have classified different types of mass movements as per, according to a triangular figure. We have placed three types of pure processes, that is pure slide, pure flow, and pure heave at the three vertices of the triangle. We know that slide and flow are fast processes or fast mass movement processes. So we have placed these slide and these flow in the range of fast moving processes, whereas we know that the heave is a slow moving mass movement process. So we place heave at the slow segment of the triangle. Now we also know that slide is a generally a dry process, dry mass movement process. So here we can see that we have placed slide near the dry segment of triangle, and flow, which we know that it consists of abundant amount of moisture. So we have placed flow in relation to the wet segment. Now we also know that heave is a transitional process from dry to wet. So we have placed heave just between the dry to wet, and we can see different types of mass movements related to these three pure types of mass movements, which we are going to devise in this triangle. Now, first rock slide. So rock slide can be inferred as near to the pure slide process, yeah, pure slide mass movement process. Rock slide consists of fast moving materials which are nearly 100% dry. Now telescrete, we can say that telescrete is a dry type of mass movement process, but which is moderate in a space. Now seasonal soil creep, because now soil creep and talus creep have a major difference of velocity. It is because talus consists of some moderate to coarse type of materials, but soil consists of fine to moderate type of materials, due to which the cohesion is more between the soil particles in respect to the talus and the rock particles. So the seasonal soil creep is a slow moving process, but it is dry as well. Now landslide is a transition between dry and wet mass movement process, but it is a fast moving process. We can see that it is lying on the line of fast moving mass movement processes. Now solifluction. Solifluction is the slowest type of mass movement process. Slowest type of mass movement process which contains abundant of moisture. Which contains abundant of moisture. We are going to study about solifluction and other mass movement processes in detail in upcoming slides. Now we are going to study about mud flow and earth flow. So when we see mud flow and earth flow, we can see difference in mud flow and earth flow in relation to wet and dry. So earth flow, which consists of moderate type of particles, and mud flow, it consists of a fine type of particles. So mud flow consists of more abundance of moisture, because fine particles can absorb the moisture better than the moderate and coarser type of particles. In speed, or in base, the mass movement processes of mud flow and earth flow are same because they both are they both are divided they both are sub processes of the flow. Now river, we know that river is the fastest moving and have abundance of water as we see, so it is the extreme type of flow mass movement process. Now factors contributing to the occurrence of the mass movement. So there are different factors which can contribute to the mass movement processes, but we have divided the factors into two headings. First, factors contributing to increased shear stress, and then factors contributing to reduce shear strength. So we can say that shear stress and shear strength are uh, uh, inversely proportional to each other. So if shear stress increases, shear strength decreases, and if shear strength increases, shear stress decreases. These are some factors which can increase shear stress, like removal of lateral support through undercutting or slope steepening, removal of underlying support, loading of slope, lateral pressure, transient stresses. These are some factors which cause to increase the shear stresses, and there are some examples which cause these factors to cause the increase in shear stress. Now these are some factors which causes the reduced in shear strength, like weathering effects, and change in core water pressure. We say that with increase in core water pressure, there is reduction in the shear strength, and when there is reduction in the shear strength, there is increase of shear stress as well. Now changes of structure. And change in the structure, we can say that creation of fissures in shells and clay, remolding of sand and sensitive clay. So if there is creation of fissures in shells and clay, they naturally have less interlocking and have less shear strength. So if they have less shear strength, conversely they have more shear stress as well. Now organic effects. So when animals make burrows in the soil, they generally lose the soil particles. Though effective shear strength decreases, which can increase the shear stress conversely. Now, different types of mass movement processes. First, we are going to study about creep. So by definition, creep is the slow plastic deformation. What is plastic deformation? Plastic deformation, we can understand plastic deformation and elastic deformation from this diagram of Hooke's law. So this is the yield stress. Yield stress is the limiting stress above which, if stresses continue to apply on an object or any rock mass, the apply on the object or the the rock mass attain a permanent deformation stage from which it can't come back to its original stage. But if yield stress is lower than stress is lower than the yield stress of up to the yield point, the object is said to be in the elastic deformation stage, where when we remove the stress, it can bounce back to its original shape. So creep is a plastic deformation. It means that due to some stresses, when creep happens, the creep is a stage of plastic deformation. That is, we have crossed the yield point, that is yield stress. We have crossed the yield point of yield stress, and now the object or our rock mass or soil has been converted to a plastic stage of deformation, has been gone to the plastic stage of deformation where it can't bounce back to its original position. Now creep is the slow plastic deformation of rock or soil in response to the stress generated by the weight of the overburden. So due to the from where the stress is applied in the phenomenon of creep, this is because of the weight of the overburden. So consider a rock mass. There is a lots of overburden of sediments or soil above it. So gradually the overburden increases, and with increase of overburden, the rock mass changes its shape, and when the yield stress crosses, when the stress crosses the yield point or yield stress limit, the rock mass is converted to the plastic deformation stage. The rock mass is going to the plastic deformation stage, from when we if we clear this overburden or this sediment, the rock mass won't get to its original position back. And if we increase the burden more, there is a rupture point. If above this limit, if the overburden increases, the rock mass ruptured or breaks away. To understand the creep, we can take an example that we have an almirah in our home. We have put a suitcase full of different types of heavy materials in it over the almirah. So if we put the suitcase for 3 to 4 days, or say to 1 month, if we after 1 month, if we remove the suitcase from the almirah can bounce back to its original position if its material has a yield point, has a higher yield point. But if we put the suitcase over the almirah for years, for 2 years, 3 years, and when gradually the material loses its strength, and with increasing stress day by day, one day eventually it crosses the yield point, or crosses the limiting stress, after which it goes into a plastic deformation stage. So when we take back the almirah, or when we when we remove the almirah from the when we remove the suitcase from the almirah, we can see that there is a permanent band or permanent change of shape in the of the upper layer of the almirah due to the creep form of deformation. Creep begins when the yield stress of the slope material exceeded, as we have studied that if yield stress is exceeded, the object goes into the plastic deformation stage or permanent deformation stage. In rock, it can extend to hundreds of meters below the surface. It occurs at very slow rates. So creep occurs at very slow rates, typically 1 mm to 10 mm per annum, and is likely to be especially active where weakly competent materials such as clays are overlain by more competent beds. Naturally, if we put a hard compact material over an incompetent material, it will change. It will gradually change its shape, and the yield stress point or a yield point of the incompetent material is quite low. So when hard competent material is put on the incompact or incompetent material, it will sooner or later will pass the yield stress, and can go to the creep stage or plastic deformation stage. It occurs at very slow rates. Okay. The bending of the lower parts of the tree trunk is often cited as evidence of creep. So, if we can see somewhere that tree trunks are bended over, so we can say that the creep should have been happen in this area. But this is not a substantial evidence, because the bending of the tree trunks can be happened due to the other processes as well, or due to the other phenomenon as well. More substantial evidence is provided by the downslope curvature of the strata near the surface. So, to get a more substantial evidence of a creep in an area, we must look to the downslope of the strata. If the downslope have the curvature near the surface, then we can say that it is substantial evidence for the it is substantial for the evidence for the creep phenomenon. Another consequence of creep is cambering, which involves the extrusion of weak rocks, usually clays, either lying below or interbedded with the more rigid strata, which causes valley sides to bulge. This is just like the sandwich. When we press the two bread slices of the sandwich, we can see that the materials between these two slices of the sandwich is squeezed out. Just like it, if two competent beds have an incompetent bed like clay between them, or have overburden and a competent bed, and between that overburden and competent bed we have incompetent clay like material, we can see that increasing overburden pressure can extrude that weak rocks out, and that can increase the valley bulge, valley sides to bulge. That can happen to valley sides to bulge. Now we are going to study about second phenomenon, that is flow. In a pure flow, shear occurs throughout the moving mass of the material, and there is no well-defined shear plane. So, in the process of flow, pure flow process, we can see here pure flow process. Pure flow process happens throughout the material, throughout the moving material. There is no defined shear plane, or there is no single shear plane along which the movement is taken place. Unlike the pure slide, here we can see that this is a shear plane along which the movement takes place. But here, all over the material, the movement is taken place. There is no discrete or any unique shear plane along which the movement is taken place. Movement is taking place throughout the material. No well-defined shear plane actually. Flow is distinguished from creep by having discrete boundaries or narrow peripheral zones experiencing shear. So there are narrow peripheral zones in the creep which are in the flow which are experiencing shear, unlike in the creep movement which are gradually due to the overburden pressure. Shear is at a maximum at the base of the flow, but here the rate of the flow is relatively low and nearly all the movement occurs as turbulent motion within the body of the flowing mass. Now, here we can say that here we can see that the shear is maximum at the base of the flow, which is generally happen because as we see anything which is moving on a plane or moving on over a surface, the most shear happens at the base of the surface, at the base near the surface, at the base of the flow near the surface. But due to this also, due to this maximum flow near the surface, we can also see that there is a maximum there is maximum friction which try to stops the flow as well. So so we can see that shear is at a maximum at the base of the flow, but here the rate of the flow is relatively slow. So it is right that shear is at maximum at the base, but due to the greater friction at the base of the flow, bed of the floor, base of the flow is relatively slow at the surface, and nearly all the movement occurs as turbulent motion within the body of the flowing mass. Now, how is in this the body of flowing mass? Whatever movement taking place is it is turbulent. Haphazardly, the particles are moving here and there. We can also see that in flow, the magnitude of flow increases with height. So, at the base, due to greater friction, the flow speed is low. But when we move upwards, the flow speed increases because the friction decreases. Dry flow can occur, but abundant water is usually present. Generally, generally the in flow type processes, the abundant water are present as we have seen at the introduction of our class today. So dry flow can also occur. Dry flow can also occur. It is right that abundant water is usually present, but dry flows can also occur. They are often initiated by falls or slides, becoming flows when the moving soil or rock mass breaks up. As we have seen in the example of debris avalanche, we have seen that debris avalanche is type of flow process, yeah, flow mass movement process. So it is correct to say that flow starts from initiated or starts from the falls or slides as a flow fall or slide. But as material started to break up, the this mass movement process of the flow converted to the soil or rock, converted to the flow type of process. So we can say that flow is not an primary process; it is a secondary process which is derived from other process such as the fall or slide type of processes. Flows are categorized as avalanches, debris flows, earth flows or mud flows, depending on whether they consist predominantly of snow and ice, rock fragments, sand, sand materials, or flow. So according to the composition of the flow, we have divided the flow into different types. If the composition of the flow is predominantly snow and ice, we uh, we call it avalanche. If composition is rock fragments, we call it debris flow. If composition is sand size, we call it earth flow. And if composition material is clay, then we call it mud flow. As we have already seen that the main difference between the debris flow, earth flow, and mud flow is the presence of different types of particles. Debris flow consists of coarse type of particles like rock fragments. The earth flow consists of moderate type of particles such as sand grains or sand size materials, and mud flows consist of very fine type of particles such as clay particles. So this is the main difference between the three types of flows. Now, varieties of flow type mass movement. So, earth flows involves extrusion of slopes, ground slope, and are usually slow moving. So, we can say that earth flows are generally slow moving, but they can be fast moving. As we see in the second line of the earth flow, where the slope material is composed of sensitive soils. However, an initial disturbance can cause instantaneous loss of shear strength and promote a rapid earth flow. So, it means that if the slope, this is the slope, this is the slope, this is earth flow, this is the slope. If this slope is composed of sensitive soil materials such as clay, because the sensitive soil materials like clay, because they are loosely banded, they are loosely binded. So if any so if any initial disturbance happens, they will instantaneously they will instantaneously lose their shear strength. These particles instantaneously lose their shear strength and promote a rapid earth flow and promote a rapid earth flow. In upcoming slides, we will briefly discuss about the shear stress and shear strength as well. If it will be easy for us to understand what is difference between the shear stress and shear strength. For till then, we should consider the shear strength as type of resistance which is acting against a stress which is going to cause the mass movement to happen. So in earth flow, we saw that it is slow type, generally a slow type of movement which extrude as a bulb at the downslope. This is the bulb extrude as downslope, and we know that earth flows consist of sand-sized particles. Slowest type of flow is solifluction. Now solifluction is a different type of slow mass movement process which involves the downslope movement of saturated soil. Saturated soil means water laden soil or moisture laden soil. So solifluction is a process which consists of abundant moisture. Solifluction can occur at slopes angles as low as 10 and is particularly active in periglacial environment. So solifluction can also take place at a slope angle less than 10 degree, and it is particularly active in the periglacial environment. What are periglacial environment? So periglacial environment is the environment present at the periphery of the glacial environment. Glacial environments are highly composed of the ice and snow. Ice masses. But in periglacial environment, we will see a subsurface layer of soil, subsurface frozen layer, above which there is a layer of soil which will goes through a cycle of freezing and thawing, continuous cycle of freezing and thawing. Here, abundant moisture is made available by seasonal thawing of soil above a frozen subsurface. So, as we have seen that periglacial environment consists of a frozen subsurface above which there is a layer of soil which goes to seasonal thawing. Seasonal thawing it means seasonal melting, and this seasonal melting process. Um, um, this melting process give the abundant moisture or make the abundant moisture available for the process of solidification to occur. Now in this periglacial environment, if solidification occurs, we give this process a different name which is known as the jellyfluction. In addition to the transport of material from higher to lower elevations, flows can be effective erosional agents, especially with more energetic variety. Up to this discussion, we have seen that different type of mass movement process, or the particularly the flow type of process, is a process which will carry materials from upslope to the upslope to the downslope due to in the influence of gravity. But some of the flow processes like debris flow, debris avalanche, which are more energetic processes, they also act as an erosional agent. So they also help in the weathering, erosion, and transportation of different types of sediments. This is particularly true for debris flows and for debris and snow avalanches which travel over the ground rather than predominantly through the air. So this behavior, or this erosional behavior of such process like debris flow and debris avalanche is is particularly helpful in erosion because they travel over the ground rather than predominantly through air. So predominantly through air, we will see it in section of fall, that when from a cliff or a steep slope, when a rock falls without touching the ground or negligibly touching the ground, we will call this process as the fall process. And through the air, these blocks or these fragments or materials are falling from the cliff. But in the process of flow, we see that there is a continuous connection of flowing material and the ground surface. So this type of processes such as the debris flow and the debris avalanche, which are the energetic process due to the presence of moderate to coarse type of grains, they are very helpful in erosion and denudation type of processes. Now, the major geomorphic effects of the avalanche are the removal of debris from gullies and slope faces. So avalanche causes the removal of the debris from the gullies. We have seen that small channel-like features are formed from which avalanche occurs. They remove debris from that gullies, and also the slope faces. When avalanche move from these slope faces, it continuously erode the material and also carry the debris present on those slope faces with it to downslope. The excavation of rock to form avalanche chutes. The avalanche also form the avalanche chutes by the excavation of rock in its journey towards downslope. Erosion and redistribution of unconsolidated slope deposits, and also it cause erosion and redistribution of unconsolidated slope deposit. Unconsolidated slope deposit means not hard rocks that are deposited over the slope from where the avalanche is passing by. So avalanche causes the erosion of that unconsolidated rock particles or soil particles or debris particles, and then deposits it to downslope. They are largely confined to terrain characterized by high local relief and steep slopes, and are thus most common in active orogenic belts. Now we have seen that as debris avalanche and snow avalanche are contributing factors in erosional and denudational type of processes. So for this process to happen, for these energetic flows, there must be a high local relief, and along with high local relief, the slope must be steep, so that energetically these flow happens, and they help in erosional type of processes. And such high local relief and steep slopes are we found such a high local relief and steep slopes in the areas of the active orogenic belts such as the Himalayas, Alps, etc., and any other orogenic belts or mountain building belts. Now, one question arises: why some avalanches achieve extremely high velocities? We know that avalanche is a high velocity phenomenon, but some avalanches achieves extremely high velocities in their journey. So this is because some avalanches may ride on a layer of compressed air trapped between the avalanche debris and the ground surface. So we are going to study that this is the slope or a path of avalanche passing, and this is the material of avalanche. Now, between this material and this ground surface, there is air trapped. There is trapped air, which act to reduce the friction between the material and the ground surface. So this trapped air has the effect of sorry, greatly reducing the frictional drag on the moving mass. So one reason is that because the reduction of friction causes the high velocity of the avalanches. Other possible explanation is fluidization, where fine particles are kept in suspension by a flow of air, and cohesionless grain flow, in which particle motion is sustained by continuous collisions as in the fluid. So air is a fluid. We all know that air is also a fluid. So between the air present between this material and the ground surface, the particles move in a suspension in this trapped air. Moving particles in trapped air, particles move in a suspension and they collide with each other. So due to this collision and this suspension type of movement of the particles, there is a cohesionless surface between these moving materials and this ground surface, which can increase the speed of the moving of the material far uh, beyond a certain limit. Now slide. Third phenomenon is slide. In a pure slide, failure occurs along a well-defined shear plane. Now, the main difference between the slide and flow we are here seeing is that there is a presence of a well-defined shear plane in slide mass movement process. We have seen that in the flow type of mass movement process, there is no well-defined shear plane or no single shear plane. The movement of materials was happening all throughout the body of the material. But in slide type of process or pure slide, mein failure occurs along a well-defined shear plane. There is presence of a well-defined shear planes along which movements of failure occur. Resistance to movement falls sharply immediately the initial failure takes place. So whenever an initial failure takes place, whatever the resistance present against the flow, it is removed, and then downslope movement continues until there is a sufficient increase in resistance, often related to a decrease in slope angle to halt it. For example, take a terrain. This is a terrain. Due to abrupt increase in the slope, here, the resistance of the particles, the abrupt increase in the flow here, the resistance which particles carries is generally removed, and then materials starts dissipating downslope. But as here we can see that there is a lowering of the slope below. There is this lowering of the slope, lowering the slope in downward area or downward region. We can see that here, due to lowering of the slope, the friction increases. Or the resistance increases, due to which the process of the slide mass movement stops here. Slides are nearly always long in relation to their width and depth, their length to width ratio typically being 10:1. So the length to width ratio, that is, when we see the frontal portion of the slide, this is length, this is width, this is width. So this length is 10 times that of this width, and due to this 10 times 10:1 ratio between length and width, slide is a fast moving mass movement process. They can be subdivided. Now slides can be subdivided into translational slide and rotational slide. In translational slide, predominantly planar shear surfaces. There are present planar shear surfaces. The main difference is that in translational slide they are present planar shear surfaces, whereas in rotational slides the shear plane is concave up, like here. It is the rotational slide. Here the shear plane is concave up, failure plane or shear plane is concave up. Here shear plane is planar or nearly planar. So this is translational slide. Rotational slides are most common where slopes consist of thick homogeneous material such as clays. Now, rotational slides are most common in the areas where slopes consist of thick homogeneous materials such as clays. When loose and thick homogeneous material, the same material such as clays are present in any area, rotational slide happens most. The rotational movement can result in the upper part of the slumped mass being back tilted towards the failure surface. Now, how rotational movement happens? So, in rotational movements, we are seeing that here is a curved failure surface, and there is present the slump. There present the slump. That is the material. Now, there develops fissures in the process of rotational slide. There develops fissures or transfer cracks in this slump present, and the upper portion of the slump, upper portion of the slump back tilted towards the failure surface, whereas the lower portion of the slump moving downwards and converted to a flow type of process, as we have seen earlier that flow starts as a fall or slide and later converted to flow process when the rock fragments started to broken up. So when rock fragments or the material fragments started breaking up, this lower part of the slump material converted to flow at the foot side of the rotational slide process. The rotational movement can result in the upper part of the slump mass being back tilted towards the failure surface. Material can move as a single block, but usually it is broken into several discrete segments separated by transverse fissures. Now, we have seen that the material can move as a single block. There can be two types of rotational slide processes. One that the slump material can move as a coherent mass or as a single mass, but generally the slump material developed some transverse fissures among them, and due to these transverse fissures, the upper portion of the slump tilted back towards the failure surface, whereas the lower portion of the slump materials converted to a flow type of process due to the breaking up of the rock fragments. Movement at the base of the rotational slides in clay or similar cohesive materials often transformed into that of an earth flow, and this gives rise to chaotic hummocky surface. So, due to the breaking up of the material, when the lower portion of the slump material converted to the earth type flow or a debris type flow, it is converted to a turbulent, haphazard movement of particles, and it forms a hummocky type surface. We have seen that hummocky cross stratification, where surface is where surface is uneven, surface is uneven. Sometimes somewhere it is bulged, somewhere it is depressed, so it is this hummocky type surface. Both rotational and translational slides are precipitated by temporary excess of shear stress. Now, both rotational and translational slides happens when there is a temporary excess of shear stress over shear strength. Now, here it is important to take a look on the shear stress and shear strength. Now, shear stress, some people think that shear stress and shear strength are same, and they use it synonymously, but definitely shear stress and shear strength are different. Shear stress is the force tending to cause deformation of a material. So shear stress is the force which is tending to causing which is going to cause the deformation of the material by slippage along a plane or planes parallel to the imposed stress, whereas the shear strength is the resistance force or is the resistance against that shear stress that cause the material's internal structure to slide against itself. So shear stress and shear strength can be we can say that they are inversely proportional to each other. If shear strength is more, they are opposite to each other. Shear stress which is going to cause the slippage, but shear strength is the resistance which stops the shear stress to cross a certain limit. Slides in a bedrock are less common but may attain enormous. Normally, slides in the bedrock are less common. They are not common in bedrock. But if they are present in the bedrock, they attain the enormous dimensions and involve the movement of the millions of cubic meters of the material. Very large slides usually break up to form debris avalanches, but in some cases, the rock travels a significant distance as a coherent mass. So we have seen earlier that there are two options for the slump to move. Either it can move as a coherent mass, or either it can move by developing transverse fissures and converting to the flow type of mass movement. Now, if it moving as a coherent mass, this is most likely to occur where competent beds slide over incompetent strata, often clay or mudstone, dipping steeply, roughly parallel to the ground surface. Now, movement of slump as a coherent mass happens in an area where there is presence a competent bed or competent mass which is going to slide over an incompetent state or incompetent mass like of clay or mudstone. Such conditions contribute to low shear strength and enhance the probability of slides occurring. Now, due to the presence of these incompetent strata below the competent strata, there is a situation which causes the shear strength to reduce, and generally when shear strength reduces, the shear stress increases, as we have seen earlier, and thus enhancing the probability of slides to occur. Now, heave. In pure heave, slope material experiences cycles of expansion and contraction. So there is cycle of expansion and contraction in the process of heave. Expansion and contraction. Let us assume it is a slope and there is a material present over this slope. Now, downslope movement. Now, in the process of heave, the downslope movement arises from the fact that while expansion occurs normal to the sloping ground surface, contraction under gravity tends to be more nearly vertical. Now, in this process of heave, in materials there is a process of contraction. There is a process of contraction and expansion, and the processes of expansion and contraction happens in such a way that expansion happens normal to the surface of the ground or sloping surface, whereas the process of contraction happens generally vertically. And due to this different types of expansion or different orientations of expansion and contraction process, there is a movement or downslope movement of the material. Two types of heave can be distinguished on the basis of the size of the constituent particles. If we classify the heaves from size according to size of the downsloping particles, we can classify them into soil creep and the talus creep. So by the name we can understand that the talus creep consists of the moderate to coarse type of fragments, whereas soil creep consists of fine grains or fine fragments. Expansion and contraction can be caused by wetting and drying. Now we have seen that the process of heave is the heave happens due to the continuous expansion and contraction of the materials. But why this expansion and contraction of the material happens? This is because of the wetting and drying. Now, wetting and drying in the lower latitudes or in the area consisting of moderate to high temperatures. So when there is a wetting of materials, there is a wetting of materials, the soil or material expands. When they expands, this expansion happens normal to the sloping surface. Now when the moisture in those materials again removed, and there happens contraction, which is generally vertical. So this causes downslope movement. Now freezing and thawing is another process due to which expansion contraction happen, but this freezing and thawing, this can happen only in high latitude regions, because or in low temperature regions generally. So in this case we describe it as the frost wave. What is freezing and thawing? Now when this material is saturated with water and when the temperature is very low, the freezing happens, and we know that when freezing happens or when the water freezes, it expands. So there happens expansion of the expansion of the material due to this freezing condition, which is generally normal to the sloping surface. Whereas when temperature increases, there is a process of thawing cycle. There is a process of freezing and thawing. There is a cycle of freezing and thawing happens, and thawing due to the thawing or melting process, the moisture is generally removed, or the freezing condition is generally removed. So when ice is converted to water, it contracts. So this contraction happens generally vertically to the generally vertical. So this is the another process of freezing and thawing which happens in the low temperature regions, which is described as the frost creep. We can describe this process at low temperature as the frost creep. Now another causes for expansion, contraction, or temperature changes, and the burrowing activity of the worms and the other organisms. Now the rate of soil or talus creep on a slope depends on a number of factors. So at the rate at which the talus creep or soil creep happens can depend on number of factors, such as the slope of the terrain. Naturally, we know that if we increases the slope of the terrain due to the increase of the slope of the terrain, the downslope component of the terrain increases. Because of increase of the downslope component of the terrain, there is a higher movement of the materials and rapid movement of the materials to the downward region. So the rate of soil, it will become greater with increasing slope angle, as we have seen that if we increase the slope angle, the downslope component increases, which can increase the movement of the material. Now the rate of soil or talus creep is also high in the soils which contains abundant quantities of clays which are immature clays, such as smectite, which expand significantly on wetting. Smectite type of clays expand significantly on wetting, and when they expand uh, significantly on wetting, and when they lose moisture, they contract significantly. They also contract if they expand significantly on losing moisture, they also contract significantly, due to which the process of expansion and contraction happen at a greater rate than normal. So the rate of soil or talus creep on slope increases. Now, if there is a silt side material which is capable of substantial ice accumulation, then the process of freezing and thawing increases, because the amount of ice which is accumulated in this silt side material is increases, and due to the increase of this freezing and thawing processes, there is a general increase in the process rate of the soil and talus creep, or generally the frost creep. Here we can't use the term soil or talus creep, we can use the term frost creep for the ice accumulation. Soil in talus creep will, however, decrease with depth below the slope surface, both because of the moderation of changes associated with wetting and drying and freeze thaw, and the increase in the weight of the overburden. So when we go downward from this region, we can see that the effect of the soil or rate of the soil and creep process, talus creep process will decrease. It is because when we move downward or at depth from the surface, there is a negligible or very low amount of process of wetting and drying, or very low significance of process of wetting and drying, freeze and thaw presence at the depth. So due to this insignificant amount of these processes present, when we go downward, soil and creep processes will decrease with depth, and this insignificance of the wetting and drying and freeze and thaw process happens due to the increase of the weight of the overburden. On steep grass-covered slopes, flights of narrow steps called terraces are commonly present, and it is likely that these are related to soil creep. So in some steep grass-covered slopes, this process of soil creep or talus creep, or this process of heave can cause the formation of terraces like terrace-like features. Now, the process of fall. The fall involves the downward motion of the rock, or more rarely soil, through the air. we have seen the process before fall. We have whatever the process we have studied before the before this fall process. There is a movement of materials down slope. There is movement of material down slope in which there is a continuous connection between the materials and the ground surface. But in the process of fall, there is no connection between the slope and sloping surface and the materials falling. So we can say that the materials falling through the air in the process of fall. Like in this diagram, when the rock fragments or whatever the boulders, pebbles and etc other materials which have fall, they have no connection with this slope. This is the steep slope. They have no connection with this steep slope. So these materials which have fall or which have come down slope from this cliff are said to have experienced the rockfall condition. Soil is not frequently involved for the simple reason that free fall can only occur from a very steep slopes or cliff faces, which of course have very little soil cover. So we have saw that fall process happens where there present the cliff faces and the steep slopes, and we know that at the cliff faces or steep slopes there is very less soil cover present, so soil is generally not involved in this process of rockfall. An exception is the toppling of the slabs of the earth along river banks, a process often referred to as the bank calving. So this process of bank calving can be said as the bank cutting. That river, we know that river during its flow started to cut the lateral sides and as well as causes the undercutting of the valley. So when undercutting of the valley happens, this is and when the lateral sides and undercutting of the valley happens, we can say this is process of the bank calving. Now in this process of the bank calving, the terrain present like that. From here, the boulders, pebbles and other materials moving downward moving downward, they move they can be called to face the toppling condition. Condition, it means that they are rolling, not just falling freely from the cliffs. They are rolling down the slope. They are rolling down the slope towards the bottom of the region. Bank calving. This arises from the undercutting of the banks by streams, and it is a very common phenomenon which contributes large quantities of sediments to erosion. Topples are distinguished from other types of the fall by rotation of the block of material as it falls away. As we have seen, there must be a rotation of the blocks. If we have to say a condition as toppling condition, there must be a condition of the rotation of the blocks. And it differs in rockfall or other types of fall, as rockfall and other types of falls involve the coming downslope of the material without any rotation or any or without any rotation. Now rock can become detached as a result of various physical weathering processes, including pressure release and joint widening by frost action, and the fragments produced are rapidly removed under gravity. Now we have seen that particles present over the cliffs or the rock fragments, rock boulders present over the cliffs fall downslope through the air. But how these rock fragments generated? So they are generated due to the physical weathering processes, various physical weathering processes, including pressure release. Pressure release includes we have seen the process that when there is a rock mass present and where there is a high overburden of pressure, when relatively we if we remove the pressure or we remove the sediments from this region, the due to this elastic deformation, due to this elastic property of the rock expands on removing this overburden. Due to this expansion, it has developed some cracks and fissures in it, due to which gradually it will disintegrate into the different fragments and will fall from the cliff. Other than that, joint widening by frost action. Now in the low temperature regions, when these type of fissures and cracks are formed, the water seeps into these fissures and cracks, and when the water freezes, it expands, and due to this expansion of water on freezing, the cracks will widen up, and such continuous process of freezing and thawing or frost action will cause general disintegration of the rocks. Rockfalls are common phenomenon in terrain characterized by high, steep rock slopes and cliffs. So generally, naturally, to fall freely or to fall through air, we must have terrain which have steep slope and a rock cliff present. Now, the process of subsidence. So subsidence can occur either as more or less instantaneous collapse of material into a cave or other cavity collapse, or as progressive lowering of the ground surface, settlement. So these are two processes which can have their place as subsidence, which can be said they are the sub process of subsidence. So there is main difference between the settlement and cavity collapse. Cavity collapse is an instantaneous collapse of material into cave or cavity, and settlement is a progressive lowering of the ground surface due to some phenomena, due to some other processes. Now, cavity collapse is largely confined to limestone terrains. So, cavity collapse is largely confined to the limestone terrains where roofs of underground cavities occasionally collapse. Where roofs of underground cavities occasionally collapse. So, we have seen that if there is a region like this is a limestone terrain, this is a terrain. This consists of limestone. And there is moving water, and there is underground water which is moving from this region. We know that the water moving or water generally dissolves the water generally dissolves the calcium carbonate or limestone, calcium carbonate of limestone, calcium carbonate limestone. Due to this dissolution of this limestone, dissolution of this limestone, there forms a cavity here. And due to formation of this cavity, gradually this upper roof of the terrain upper roof of the terrain instantaneously collapse, and this is called the cavity collapse. More rarely, lava tubes within lava flows may experience a similar effect. Cavity collapse can also occur as a result of human activities such as mining. And we can also see cavity collapse due to the human activities, like in this terrain. We take this terrain uh, for example. There is a terrain where they are present where they are happening mining. In this region, mining is continuously taking place, but after mining, if the cavities which are generated due to the mining of the material, if we do not fill this cavity properly, so the roof present above this cavity can collapse instantaneously wherever the overburden pressure increases from a certain limit. Settlement usually arises from the lowering of the water tables. Now, settlement or the progressive lowering of the ground surface happens due to the lowering of water tables, and is most dramatically illustrated in area where has been oil drilling or large scale abstraction of the ground water for irrigation. So we can easily say that the settlement process can happen due to the haphazard abstraction of groundwater or extraction of the oil, or due to the oil drilling. Due to this oil drilling and the haphazard abstraction of groundwater, the water table or generally fluid layer is generally decreases downward gradually, and there is a progressive lowering, not an instantaneous, but this is a progressive lowering of the ground surface, progressive lowering of the ground surface with the downgrading of the water table. Settlements can also occur naturally where the volume of poorly compacted materials is decreased by addition of water or by vibrations such as those generated by earthquakes. Now, the vibration which earthquake generated can also causes the settlements to happen. Also, if there is present a poorly compacted material or poorly compacted soil, Then it goes to hydrocompaction. Hydrocompaction, it means when we added a large amount of water in this poorly compacted soil, the volume of this poorly compacted soil increases. Due to increase this volume, there is gradual or progressive lowering of the ground surface. There is gradually or progressive lowering of the ground surface, which is known as the settlement. Now in this diagram, we can see that this is a example of settlement. This hole is created due to the process of settlement or cavity collapse. We can't say that. It can be due to the mining or due to the lowering of the ground surface, whatever the reason. Now we will see some diagrams and we try to infer about the processes involved. Now in this process we can see that these trunks are bended. So in the process of creep, we have seen that the bending of the trunks can be the evidence of the creep. They are not substantial evidence, but they can be the evidence of creep. So we can say that this can be creep, but after a substantial study of the area. Now this we can see this is a flow type of process, and it consists of very fine type of material. So we can see that it is a mud flow. Now this is a type of slide. Whatever it is, a translational slide or rotational slide, we will look at after a thorough investigation of the area. But we can see this is a shear plane or failure plane from which movement of materials takes place or failure takes place. Now this is an example of rock flow. We can see that rock is generally falling through the air or without any significant connection with the ground. So we can say that it is rock fall. And this is the process of subsidence. We have already seen it during our discussion of subsidence process. It can happen due to the mining or degradation of the water table as well. Now last, we are going to study about the importance of mass movement processes. Why to study mass movement processes? So importance of the study of the mass movement lies in the fact that such movements affect the geomorphological studies of an area. Studies related to the landforms and features developed in an area directly or indirectly affected by the different types of mass movement taking place in that area. So we can say that whatever the landforms and features which are developing in an area, they are directly or indirectly affected by the different types of mass movements taking place in that area, because the development of a landform and their gradual denudation, their gradual degradation can have different types of effects in that area lithology and that area's geomorphology. For example, a study which has been carried out in a river profile has to be rectified again and again because of the abundant phenomenon toppling. We have seen that the river profile or the river section consists of abundance amount of toppling process happening, gradual process of toppling happening. So due to the undercutting of the banks or bank carving process and due to the toppling as well, the general geology and the general geomorphology of that river profile is changing day by day. So we have to rectify our records again and again if we are studying that river profile for a long time of area for years. Phenomena related to mass wasting are one of the important cause of relief degradation. We have seen that the mass movements and mass wasting are not synonymous, but mass wasting included the important cause of the relief degradation. Now, the studies related to the mass movement helps researchers to prepare a detailed account related to the processes that were present and were abundant in that area of interest. We know that different types of mass movement processes happens differently, and they also consist different types of materials within them. If there happens debris flow or there happens transitional slide, we can say that slide is type of a dry process, but flow is type of an water laden process. So whatever the process happening in that area, we can infer about the geology and about the presence of different types of lithologies of that area by studying the mass movement processes happening there. Different types of mass movement depict different processes and phenomena acted in the area of interest, and assist the researchers prepare paleogeographic account of the area and the processes that have changed the landforms present in that area. Study of mass wasting processes helps to account the presence of moisture and other factors in that area. So thank you. We are going to end our discussion here. Hope I have made myself presentable and understandable to you. Thank you so much.